everyone, we're going to find the sum of the series given here, and what we're going to do is look at this inner function first, because this is based off this formula here, and we can look at this and rewrite it as the sum from k equals 1 to n, and I can write this as 2 to the power of k, and then times 2 to the power of n minus 1. Because what we want to do is match up these n's and these k's. So basically what we're going to do is write this as the sum from n equals 1 to 5. And then for this piece, I'm going to write this as the n I'm going to put first. So this is going to be 2 to the power of n minus 1, because that goes with your n minus 1. And this is going to be times the sum from k equals 1 to n, since we're starting with k, and 2 to the power of k. All right. So now what we want to do is deal with this. So we're going to copy this down. The sum from n equals 1 to 5 of 2 to the power of n minus 1. Now this piece here is going to be your first term. If you substitute in 1, it's going to be 2. And also your common ratio, r, is also going to be 2. So I can write that using this formula as 2 times 2 to the power of n minus 1, all divided by 2 minus 1. All right. So simplifying this, we're going to get this equals the sum from n equals 1 to 5, and we have 2 to the power of n minus 1. Now, this is just 1, so I'm going to cross that out. I'm going to distribute the 2. So 2 times 2 to the power of n is really going to be 2 to the power of n plus 1 minus 2 when you distribute that. All right. Now, let's go ahead and clean this part up and multiply these two. So basically, when you multiply these two together, we're going to get the sum of n equals 1 to 5. And this is going to be 2 to the power of n minus 1 plus n plus 1. So what happens is the ones cancel, and you're going to get 2 to the power of 2n. Minus, now let's do this one. So we already have the minus. This is going to be 2 times 2 to the power of n minus 1. So when you do 2, we have the same base, so it's going to be 1 plus n minus 1. So that's going to be 2 to the power of n. So basically, we can multiply this or write this as 4 to the power of n. So let's do that. We're going to have the sum of n equals 1 to 5, and we have 4 to the power of n minus 2 to the power of n. All right, just using our formula here, this is going to give me, again, your first term is going to be 4. So you're going to 4 times 4, and our n is 5, so you do the power of 5 minus 1, divided by your common ratio is 4 minus 1. So this, the first one, a is 4, and r is 4. The second one, a is 2, and r is 2. So then we're going to subtract the same thing, 2 times 2 to the power of 5 minus 1 divided by 2 minus 1. All right, this is going to give me, let's see, for this one, this is 3. So we're going to have 4 divided by 3 times 4 to the power of 5 minus 1. Minus, this is just 1, so we're going to have minus 2 times, well, let's go ahead and multiply the 2 since we have some time here. So 2 times 2 to the power of 5 is 2 to the power of 6. and then minus 2. Put this in parentheses here. All right, now this is going to simplify to, let's let this be 2. So 4 divided by 3, and I can write this as 2 to the power of 10 minus 1. And then this one's going to end up being 2 to the power of 6 is 64 minus 2. It's just easier to do it this way, 2 to the power of 10. I think most people have memorized. So this is 4/3. This is 1024 minus 1. This is going to be minus 62. So what we're going to end up getting is 1,364 is this piece minus 62. So your final sum is going to be 1,302. And that's your final answer. Thank you. Have a nice day. Bye-bye.